Well, now that we've looked at the for loop as an example of a counted loop, let's take a look at a category number 2, and that is the logic loops. And this example here is just going to show you how the structure of the loop works. It's not very practical, but a real practical example would be to say, as I talked about earlier with the robots, take the robot, visualize a robot on the ground, say, I want you to move forward until you get within a foot of an obstacle, and I want you to stop, turn around, and go the other direction. And if the batteries don't die and it doesn't fall off the cliff or something, it'll just keep doing that for a long time and run around the room. That's very different than saying, I want you to move 14 inches and then turn right and do something else. So you see the difference? So logic loop is waiting until some condition is true. Now if you look at this, there are two variations on this, a while loop and a do while. And there's a subtle difference, but it's an important difference, particularly when you get to reading and writing from a hard drive. The while loop gets set up a little differently, and you can see here that what I did was I said I'm going to have a counter called x. I'm going to start at 1, and I'm going to have a total of 0. Now what I want us to do is I want the loop to start at 1, and I want it to go all the way down to 9, and every time it adds a number, 1, 2, 3, every time it goes around, I want it to keep track of a total, so at the end it will tell me what is a total of 1 plus 2 plus 3 plus 4 plus 5. Okay, that kind of a deal. That's why I'm doing this. And this is just to show you the structure of how this works. So I'm going to create a variable. Now this is not a loop control variable. This is just a counter that I'm going to use. And the total is going to be whatever this total is down here. Okay? Now I'm going to print out x in the list box just like I did before, so we have some output. And the variable total is the thing that's going to give us the 45 here. So here's what I'm going to do. I'm going to set this up and I say type in while, and again these are very similar to the for and the if statements. The thing that you're trying to evaluate and do is in rounded parentheses, no semicolon, and there's because you're not telling it to really do something. We're doing this as a counter or an evaluation. So while x is less than 10, do what's in this block of code. You see this? And there may be one line, there may be 20 lines. That's what this means. While x is less than 10, do what's in this code. So you have to put in a left and right hand curly braces for this block so the loop knows what to do. Notice it doesn't say start at 1 and go anywhere. It doesn't go count by backwards by 2, ahead by 5, nothing. It has nothing to do with counting. It has to do with until something is true or false, then it stops. So we're going to come in here and we're going to say, the first thing we're going to do is say the total plus equals x. So x, the very first time, x is 1. I set that up out here, outside the loop. Now these are outside the loop. We will adjust them inside the loop. So it says total plus equals x. And now take the value of x, okay, and add it to the list box. So there's where the 1 came from. Now what I want to do is I need to increment x myself. So I'm going to say x plus plus, semicolon, and now my loop is going to run again. It doesn't say run again, but that's what it's going to do. It's going to come up here and x is now 2. And as I say, well, I'm going to keep doing this while x is less than 10. I'm supposed to keep doing this. So it's going to do it again. So it says a total plus equals x. Total is now equal to 1 plus 2. And it's going to take x, which is 2, and pop it in there. And then it's going to increment x. Now x is 3. Is it going to run again? Yes, because x is less than 10. So now it's going to add that to the running total. It's going to put that in there. It's going to keep going as long as x is less than 10. When x equals 10, this whole loop stops. It's going to come down here and it's going to add a space, so I can have a space here for you. And then it's going to put in total, and I'm going to append total here. And then I'm going to show this code. That's what this does here. Ignore that part. That's what makes this whole thing run. Okay, but that's how a while loop runs. I want you to write something down. This is very important. This loop is called a pre-tested loop. And here's what I mean. The evaluation as to whether the loop is going to run or not happens before any of the code inside the loop is processed. You see that? Now up here somewhere in my code or somewhere else, if x was equal to 10 or 11 or 12, come down here and say the loop, and let's say x is already 12. Is this loop going to run? No, It can't run because it says, well, x is less than 10, I'm going to run. If x is 10 or greater, this guy won't run. So on a pre-tested loop, the only thing you could answer on a test when I said, how many times can you guarantee that this loop will run? The answer is, you can't guarantee that it'll run at all. It may never run. And I want you to see why. And that's a very important structure that you need to understand, because the one I'm going to show you in a minute is kind of the opposite of this. Okay? So I hope you can see that. If this is true, while x is less than it, then it's going to run whatever in here. If this is not true, it quits. Now let's look at the other one. This is called a do-while loop, and it's kind of just flipped around. Notice here I have exactly the same thing, and I'm going to go from 1 to 15, and I'm going to then keep a running total. Same thing, I just used more numbers. Except this time, my while part is down here at the bottom, and up here there's a command called do. Now when you see something called do, what that means is it says do what is in the block of code right underneath it. So it's going to do all this stuff. Okay? It's going to keep doing that block of code while x is less than or equal to 15. It works the same way. We're going to increment the total. We're going to increment x. But the difference between this and the other one is this one right here, this is called a post-test loop. In other words, the test or the evaluation as to whether the loop keeps going is at the end. So, on a quiz or a test, if I asked you how many times can you guarantee me that this loop will run, a do-while loop, the answer is at least once. And the reason is, when you come up here and it sees do, there's nothing to tell the computer not to run it. It has to run it. It says do this. So it'll do it at least once, and then it's going to do an evaluation. This is something I want you to write down. This is something you would never do. You don't use this one when you're reading and writing from a hard drive. Because what if the file isn't there? What if the network's down? What if the computer's off? What if there's all kinds of things that can go wrong when you're trying to read and write to a file? So if you did this, it could very easily fail if the file wasn't there or the data was corrupt. If you're going to read and write to a file, you always use a pre-tested loop like this. Because now, if it goes in there and it says, run this while there's something to read, there's code similar to that, then you're going to be okay. And if there's nothing to read, then it's not going to try and do this and create an error. Okay? So this is a pre-test loop, the while loop. The do-while, which is just flipped around, is called a post-test loop. This may never run at all. This one runs at least once, but it may be a problem for you. It may cause an error. Okay? Try to get a picture of the idea with the robots, because that's really a much better example than what I'm doing here. But these guys explain how the loop runs, and when we do file I/O, where we actually read and write to disk hard drive, we will use one of these, but we're not going to use this one. We're going to use this pup for the reason that I just said. All right?